In this video, we're going to do the practice for exam 1. So let's do one question at a time. So question number 1. It says to evaluate the expression when x is equal to -3 and y is equal to 5. So you're going to put -3 in for x, and then 5 goes in for, we substitute in for y. Put that in red. And so you'll have -3 plus 15, and that's going to be 12. Please try to do this without a calculator, so that way you can practice your arithmetic, which will just make you stronger as you continue to work through these questions. Next question, find the value of the given expression if x is equal to 5 and y is equal to -4, and the expression is 3x minus 2y. So now we substitute in the x, and then we substitute in the y, and that's an absolute value there. So we do what's inside first. So you're going to have 3 times 5, which is 15, -2 times -4, which is a positive 8, and that will give you the absolute value of 23. Remember, the absolute value will give you the distance from that number from 0 on the number line, or you just think the positive value until your answer is 25. Number 3. It says simplify the expression. Now what that means is you have this negative exponent. You always want to make it a positive exponent. So it'll be 11 squared, and then that will be 1 over 121. Just to recall some of the important rules for laws of exponents that you need to have. When you multiply like bases, so like bases here being those x's, you add their exponents. Next rule, when you divide like bases, you subtract their exponents. Next one, when you raise a power to a power, so you have 2 exponents here, you multiply them. So it'll be a times b. Any base to the 0 power is 1. And if you have a negative exponent, you can change its place in the fraction by moving it from numerator to denominator or denominator to numerator. Okay, let's look at question number 4. Question number 4 is x to the 9th, y to the -3rd, to the 6th power. So basically we're going to be using this rule. So this will become x to the 9 times 6, and then y to the -3 times 6. So that'll be x to the 54th, y to the -18th. Let's look at number 5. Number 5 says add as indicated. So you have x squared plus 8x plus 9 plus 4x squared minus 6x plus 8. Now if you notice, whenever you have addition of polynomials, so the only really time you have to worry is if this is a minus sign, because then you have to distribute it through. But since it's a plus sign, you don't have to worry. You can just rewrite it without the parentheses. And there's no coefficient in front that you have to distribute either. So now you look for like terms. Now remember, like terms have to do with the powers. This is a power of 2. This is a power of x to the 1. And this is your constant. So those are going to be the ones that you combine. So let's do the x squared terms first. That's 5x squared. Now let's do the x to the 1 power. That's 8 minus 6, so that's a positive 2. And then let's do the constants. 9 plus 8, that's 17. And that's your answer. Okay, now let's look at number 6. Number 6 is similar. So number 6 is calculate using the indicated operation. And if you notice here, it's similar because it's got 2 parentheses, but notice what's in between the 2 parentheses, a minus sign. So that means you're going to take all of this, you're going to subtract all of that. Remember, if you have a subtraction, you have to change the sign of everything inside of it. So let's do this again. 8x to the 3rd, don't touch this one stays the same. Now I'm going to change the sign. So I have minus 9x squared plus 3x minus 5. So you're subtracting all of it. Now let's combine like terms. Is there anything inside of these that have any of these terms in x to the 3rd? No, just the 8. So now let's combine anything with a squared. So you have -7 minus 9. So it'll be a -16x squared. Then we have a plus 4 and a plus 3, so it's a plus 7x. And then we have a minus 8 and a minus 5. And that's -13. And that's all you can do. Okay, number 7. Number 7 says to multiply as indicated. Express your answer as a single polynomial. So you're going to multiply this 2x to the third to each term inside. We're doing the distributive property. So you have negative 2 times 5, that's a negative 10. And then you're multiplying like basis, so you add exponents, so it becomes 8. And then when you multiply the negative 2 with the 4, you get a negative 8, and the variable stays. Okay, number 8. 8z plus 7, 9z minus 4. So you're going to do FOIL. So FOIL, if you remember, is first, outer, inner, last. So the first term is the first of the parentheses. So 8 times 9 is 72. Z times z is z squared. Now let's do the outer. 8z times negative 4 is a negative 32z. Let's do the inner. 7 times 9, that's a plus 63z. And then the last is the last of the two parentheses, 7 times negative 4, and that's negative 28. Your two middle ones, the O and the I of FOIL, can be combined. So it's going to be negative 32 plus 63, so that's the same thing as 63 minus 32. And then I'll give you your 31. So we get 72z squared plus 31, because that one's positive, minus 28. Okay, number 9. Number 9 says to expand this. Now you can do one of two things. You could either do FOIL here, so you have x plus h times x plus h, or you can use a special product rule that says if you have a square, this is x squared plus 2ax plus a squared. Remember, if it was a minus sign in between it, the only thing that's different is the middle term is minus. But you don't have to remember those rules. I highly recommend just doing FOIL. So x times x is x squared, x times h is xh, h times x is still xh, right, because multiplication is commutative, and h times h is h squared. These two can be combined just like in question 8, so that's 2xh plus h squared, and that would be the answer you'd input. Okay, question 10 says to factor the polynomial completely. Now, if you remember, we had that worksheet, that handout that I gave you that said GCF is what the first thing you want to look for. And then it said 2 terms, 3 terms, or 4 terms. And if it was 2 terms, look for a difference of perfect squares. If it was 3 terms, you looked for where the coefficient in front of the ace is x squared is greater than 1, or if where the coefficient was equal to 1. And if it was 4 terms, it said to do grouping. If it was greater than 1, it was the slip and slide method. If it was a is equal to 1, it's regular old factoring trinomials. And then the others have their own techniques. But this is a difference of perfect squares. So it's 2 terms, 1, 2. So when you have difference of perfect squares, the square root of x squared is x, and the square root of 49 is 7. And you're going to have opposite signs. And that's your answer. Okay, question 11. So it's 3 terms, 1, 2, 3. The number in front of the x squared is 1. So we're just going to factor it as we normally do. We look for numbers that multiply to give you 9. And they add up to give you the middle number. So that would be 3 and 3. So you have x with the 3, x with the 3. This plus sign here tells you the signs are the same. They're both positive. And that's your answer. Question 12, same idea. So the number in front is 1, so you're going to follow the same suit. Numbers that multiply to give you 22, and they add up to give you 13. So I think about my 22 factors. I have 22 and 1. I have 11 and 2. Those right there, there you go. So 11 and 2 would work. So I put x with an 11, x with a 2. They're both going to be positive, because this tells you the signs are the same and this tells you they're positive. Okay, so number 13, the directions say to factor by grouping. So notice it's got 4 terms in it. So that's also a hint to know that you should factor by grouping. But the question will tell you to do it if it wanted you to. So you'd look at the common factor of the first 2 terms and the last 2 terms. A little hint, when you do factor the first 2 terms, you should also take out an x, because if you notice, x is common to both of them. So let's factor out a 3x. 3x squared divided by 3x is just x. 12x divided by 3x is 4. Now let's look here. 4 is common to both of them, so x plus 4. Remember, your goal is that you get exactly the same parentheses as a common factor. And if you remember in the beginning of the semester, I said to you, it's really important that you understand terms. Terms are separated by plus or minus signs. So here's a term and here's a term. Notice that this x plus 4 is common to both. So you're going to now factor out that x plus 4. And when you do factor out that x plus 4, you're left with the 3x plus 4. And that's your answer. Okay, question number 14. How many terms are there? 1, 2, 3 terms. So if you think back to that chart that we had 3 terms, you look at the number in front of the x squared term, it is bigger than 1. So this is now the slip and slide method. So the slip and slide method says multiply the first with the last term, so you get 13. So instead you think of it as this. And you think factors that multiply to give you 13 and add up to give you 14. Just 13 and 1. That's a prime number. You don't have many options. So you write that. 13, 1. They're the same signs. They're both positive. But now that's not your answer. Because of the slip and slide method, what you did is you multiplied by 13, right? So now you're going to divide the numerical portion of the binomials by 13. So now this gives you x plus 13 over 13 is 1. And you can't keep this here, so that's what we slide it up. 13x plus 1. And that's what you're going to input onto MyLab. Okay, number 15 starts the process with rational expressions, and it really combines a lot of the work we just did. So when you have just one fraction, and the question says to reduce, what you want to do is to factor numerator and factor denominator. So in this numerator, there's a GCF, and in this denominator, there's a GCF. When you factor this numerator, x is common to both. When you factor the denominator, 2 is common to both. Notice that through the cancellation property, x plus 3's can be canceled out, and so you're left with just x over 2. Number 16. X squared plus 8x plus 12 all over x squared plus 3x minus 18. Now remember, this is just like the previous questions, but you were given, instead of given one trinomial, you were given 2. Factors of 12, when are added, give you 8. That's going to be 6 and 2. This tells you the signs are the same, they're both positive. Now let's do the same thing here. Factors of 18, when are subtracted, give you 3. So that would be 6 and 3. This tells you the signs are going to be different. The bigger one is positive. Now you look for common factors. Notice the x plus 6 and the x plus 6 are common to both, and that's it. So your numerator will stay x plus 2, your denominator will stay x minus 3. Do not cross out the x's because you can only cancel or factor if they are multiplication between them. X plus 2 is addition, not multiplication. Okay, another example still with rational expressions. Number 17, 7x plus 56 all over 8x to the 9th times x all over x squared minus 64. So now why this is different than the previous 2 questions is that you're not just given one fraction, but you're given 2. But you still have to factor all of them if you can. So this numerator has a GCF, which is 7. And so 56 divided by 7 is 8. This denominator can't do anything with. This numerator can't do anything with, but look, that's a difference of perfect squares. So that becomes x plus 8, x minus 8. So now let's use the cancellation property. There's an x plus 8 and an x plus 8. They're gone. This is division of like bases, so you subtract them. X goes into x to the 9th. It leaves you with x to the 8th. It doesn't look like I have anything left, but let's just see. So let's multiply numerators and numerators. So in the numerator, all I have is 7. And in the denominator, I have 8x to the 8th, x minus 8. And nothing else can be simplified. So that's what you will input on MyLab. Okay, number 18. 6x all over x squared minus 4 all over 6x minus 30 all over 9x plus 18. So notice now, this is different than number 17 because it's division. But remember what we said about division. When you divide by a fraction, it's the same thing as multiplying by the reciprocal. Or keep, change, flip. So we're going to keep this, change the division to multiplication, and flip that. Okay, here we go. So this x squared minus 4 is a difference of perfect squares. The 6x stays. This 9x plus 18 has a GCF of 9. And this 6x minus 3 has a GCF of 6. Okay, so remember, we can only use the cancellation property from numerator and denominator, so the x plus 2's can cross out, the 6's can cross out, and that looks like it. So we're going to multiply numerator with numerator, so I have x times 9, so that's 9x, and then I have x minus 2 times x minus 5, and keep it in factored form, because the question says to keep it in factored form. And this is what you'll input. Okay, so now this is a little bit different. Notice why this is different than 18 and 17 is because you're adding and subtracting. Totally different rules. You can only add or subtract fractions if they have the same denominator. So you need to get the same denominator. So your common denominator is just going to be the product of the both of them together. So it's going to be x minus 4 times x plus 5. So what you're going to do is you're going to multiply what's missing. So this fraction is missing the x plus 5. But be careful. You have to put parentheses around the denominators that are already there. And this fraction is missing an x minus 4. So the first one will give you 9x plus 45. I distributed. The second one will give me a negative 3 that's going to get distributed through. So it's going to be a negative 3x plus 12, because negative 3 times negative 4 is positive 12. All over, and remember, when you combine like denominators, when you combine fractions with like denominators, you just write the denominator one time. So I have to look now for common terms. Like terms, so 9x minus 3x is 6x, 45 minus 12, so 45 plus 12 is 57. And there's nothing I can factor out with that numerator, so this is your answer in completely factored form. Number 20 is going to be very similar. The only difference is instead of subtraction, it's going to be addition. So your common denominator is going to be the product of them. So x plus 2 times x minus 2. This fraction is missing the x minus 2's. And this fraction is missing the x plus 2's. So I can write it all one time and the denominator. This numerator will become x squared minus 2x. This numerator will become 7x squared plus 14x minus x minus 2. And now you look for like terms, just in the numerator. X squared plus 7x squared is 8x squared. Negative 2 and plus 14 is positive 12, and then minus 1. So that's positive 11x, and then negative 2 is just left behind. And then you write your denominator. And that's what you will input. Okay, 21 shifts gears a little, and it looks at a perfect cube. So what you're going to want to do is write out what your perfect cubes are so you'll start to remember. So 3 to the third is 3 times 3 times 3, right? So that's 27. 4 to the third is 16 times 4, which is 64. 5 to the third is 25 times 5, which is 125. 6 to the third is 36 times, 36 times 6, which I think is 216. I don't recall. But right now this is our answer that we want. But notice it's negative. So if I have negative 5 times negative 5 times negative 5, that's going to be positive 25 times negative 5. And that's why I get a negative 125. So this answer will be a negative 5. You can only have a negative number under the radical if you're dealing with an odd root. You can never have the square root of a negative number in the real numbers. Later on in the course, we'll start to look at imaginaries, and then we can. But this should signal for you that if with an odd root, if it's negative, the answer should be negative. Rationalizing denominator just means you multiply, if it's a monomial in the denominator, you multiply top and bottom by that. So 1 times radical 5 is radical 5. And radical 5 times radical 5 is just 5. That's a rule, because radical 5 times radical 5 is radical 25, and the square root of 25 is 5. But you could actually just get rid of it right away if you remember the rule. 23 is the square root of 3 all over 9 minus radical 2. Now notice that they still want you to rationalize the denominator, but you're dealing with a binomial now, so they have to multiply by the conjugate. The conjugate is exactly the same binomial, just with different signs. So now you're going to distribute. So that'll be 9 radical 3 plus the square root of 6, 3 times 2. And then this is just like difference of perfect squares. So you can FOIL it, but you're just going to end up getting the square of the first one minusing the square of the second one. But I'll show you FOIL so you see. 9 times 9 is 81. 9 times radical 2 is 9 radical 2. Negative radical 2 times 9 is negative 9 radical 2. And radical 2 times radical 2 is 2. Notice that these two go and cancel out, and you're left with 81. Oop, I forgot to sign here. Minus 2. Same thing as here. So this will be 9 radical 3 plus radical 6 all over 79. Please be careful. I checked this out earlier today on MyLab. If you keep it in factored form, you will get marked wrong. You need to distribute it through and then put your answer in. Lastly, this brings us back to one of the first rules we worked with in the video, using that rule that if you have a power raised to a power, you're going to multiply them. So this becomes x to the 10th times 1/5, and y to the 25th times 1/5. This will end up giving you to the second power, and this will end up giving you to the 5th power. All your questions from your exam will look similar to these questions, so just keep practicing this over and over again until you feel comfortable with the material.